Welcome to Math Unit 6. This is the last unit where you'll be doing actual calculations. Next unit, we're working on syringes, so there's not really a lot of calculation involved there. But this unit is IV drip rate calculations. So when you see that IV hanging by gravity and there's a slide clamp and there's drips going through, you have to calculate how many drips per minute you set those IVs for. To do that, we have to learn a little bit about IVs, not much, but just a little bit so you can better understand that. But this unit is going to primarily focus on calculating gravity flow IV drip rates for your patient.
One of the reasons we use IV therapy so much as nurses is because it's a very effective and efficient way of supplying fluid to our patients, especially when, for whatever reason, they can't drink fluids quickly enough, or maybe there's a reason they're not allowed to drink fluids, but whether we can or cannot drink them, we still need them. Normally this is ordered by a physician, but it can be ordered by a PA, a nurse practitioner can also order IV fluids for a patient. So all of those are possibilities. The thing about IV therapy, though, is it can be hazardous if it's not done correctly. You could send somebody into fluid overload, they could get pneumonia, it can get very, very ugly. That is why you have an entire section of MedSurg 2 that will be devoted to learning all of the safety stuff that you need to know about IV therapy. And it's a huge unit and it's pass-fail. And there's a reason that so much attention is paid to this area. Now, in our math practice book, this will be the exam that's on page 11. So again, don't do that until you've practiced everything and use that as kind of a dry run for your exam. So that was the container. Now let's talk about the tubing. So when you look at IV tubing, and I have a little drawing of some IV tubing coming up on the next slide, but at the top of the tubing you have the insertion spike. That's what's going to actually poke into the bag and allow the solution to get to the patient. That also has to be kept sterile. Then when you come down from that spike, you'll see a little chamber where you can see drips coming down. You know what that's called? Wait for it, a drip chamber. And it is going to be either macro drips or micro drips. Macro drip can be anything from 10 to 20, like 10, 12, 15, or 20. Those are the most common. I've got that on another slide, so don't have a cow. But micro drip is always the same thing. Whenever we say micro drip, it's always 60 drops per milliliter, always. That's one of the few constants in, there's not that many constants in nursing school, but micro drippers are always 60 drops per mil. Macro drippers, like I said, they could be anything from 10 to 20 drops per mil, but a micro drip is 60. And I know that probably sounds reversed, but what that means is it takes 60 drops to make a milliliter. So those are pretty tiny drops. That's why it's a micro drip. Then you've got the roller valve or screw clamp, whatever they have. Normally it's a roller valve these days that helps to control the rate of fluid. That's what you're going to be using to set these rates that you come up with. It's literally just a roller ball that goes up to speed up and pulls down to slow down. You've got the tubing itself, and then you've got a protective cap over the distal end, which will be connected to whatever device we used for IV access. And again, we will talk about those more in future. I put this in to help you see the difference between macro drip and micro drip. So if you look at the photo on the left, it's macro drip. Look how big that drip chamber or that drip tube is, okay, and how big that drop is. It's pretty good size. But if you look over at the micro drip, look how teeny tiny that tube that's hanging down is, and then the teeny tiny little drops that are coming down from there. So a macro drip is either going to be a 10, a 12, a 15, or a 20. There's a reason it's those numbers, okay? And that's on another slide, so don't scramble to try to write it down. Micro drip is always 60. Did I mention that a micro drip is always 60? That's something you're probably going to need to remember, say, I don't know, for a test, and then any future times that we talk about micro drips. So just be advised. So as nurses, one of our jobs is to take the order that a doctor writes for an IV, which is usually in some way, shape, or form. It's in milliliters per hour or cc's per hour. And if we don't have a pump and we have gravity tubing with that roller clamp, we have to be able to figure out how many drops per minute you have to set that IV for to maintain the rate that the doctor has ordered. So that's what we're going to be doing in this math lesson. Sometimes the doctor gives us the rate straight up. They'll say, set this IV for 100 milliliters per hour. Okay, well, you've got an hourly rate. You're done. You've got that information. You only need one more piece of information and you can figure out your math. No problem. But sometimes they write it like what's on here, and they want 3,000 cc's to go in over 24 hours. Okay, well, you now have to take that 3,000 and divide it by 24, because for our equation to work, you always have to have your rate in milliliters per hour, meaning a single hour, okay? So you will calculate the correct flow rate and regulate the infusion as you learn more about IVs. Now, right now, all we're learning how to do is calculate the flow rate. You won't regulate the IV flow in Nursing 120, but you will definitely start doing that in Med-Surg. But you have to know how many drops per milliliter you have in order to figure this out. So I said one piece of information you needed was the rate, cc's per hour. You also need to know drops per cc, or drops per milliliter. The thing is, that's going to be on the tubing container, the tubing bag, or sometimes it's actually imprinted on the drip chamber itself. But those are the two pieces of information that you need to know to figure out how fast to set an IV. So the drop factor is going to be based on the size of the drip tube diameter of each individual tubing. Now, certain manufacturers tend to pick a size and then that's what they stick with. So you'll get used to whatever size tubing that you have wherever you work, but you can always look on the package and they always identify the drop factor on the package. So what are some common drip factors? You got 10, 15, 20, actually 12 is a common one too. And there's a reason it's 10, 12, 15, and 20. I'll show you in just a second. The other one is your mini drip or micro drip. Both of those are correct, and that one is always 60. Now, here's the thing about 10, 12, 15, and 20. They are all factors of 60. So if you factored out 60, you would find a way to divide 60 evenly by 10, by 12, by 15, and 20. And there's a reason that's going to come in handy in a minute. You also need to know the volume of fluid to be infused and the specific time. So again, that's rate. Did the doctor come right out and say they want it to go 100 milliliters per hour? Or did they say 1,000 cc's over 10 hours and we have to figure out that it's 100 milliliters per hour? It just depends on the physician and how they're going to write the order. This slide will make more sense when we start actually doing problems, but basically, what you have to know first is the rate. So if they don't give you the rate outright, they don't say 100 milliliters per hour, then again, you might have to take that 3,000 cc's over 24 hours and bring it down to milliliters per hour. Because what you need in order to set this up, and you set these all up the exact same way, guys, you have milliliters per hour times drops per minute over 60 minutes. Because everything's per hour, and when you divide it by 60 minutes, then that puts it down to per minute. Trust me, you don't want to know how many drops you'd have to count per hour, nor would you have time to do that. Another way to say it is rate times drop factor over 60 minutes. And what I like to do is I like to put the 60 right under the drop factor, and the reason is they are always reducible, and it makes the math really, really simple. I'll show you in just a second. So to try to simplify this before we start doing practice problems, I just wanted to show you what we're doing. We're taking the rate times the drop factor over 60, okay? Why do we do that? Well, look over here in the right-hand corner. You see where I've got, basically I just put the units in there so you can see how we're doing it. It's like taking milliliters per hour times drops per milliliter times hours per minute. The milliliters cancel, the hours cancel, and all it leaves us with drops per minute, and that's what we want. So instead of having to write that out in one long thing, we just do it. Now move down to halfway down the page. I'm going to use a rate of 75 milliliters per hour, but I'm going to do this with two different drop factors. So the first one, I'm doing 75 milliliters per hour is my rate. My drop factor is 10 drops per milliliter, and then I'm putting it over 60 minutes. Well, the 10 and the 60 are immediately reducible. So basically, what you have is 75 divided by 6, which I've done down here. And you can see that ends up being 12.5. Well, you can't do a decimal with drop factors. It's got to be a whole number, okay? You cannot get that thing to shave a drip in half. So you're going to have to round it to 13, and so your answer is 13 drops per minute. Now, if you go to the bottom one, it's the same rate. It's 75 drops or 75 cc's per hour, but this time it's over 15, or it's a 15 drop per milliliter drop factor. Now you notice I didn't write all the units in there because honestly, you don't really have to. If you know this equation, rate times drop factor over 60, you're good to go. You're just going to take the 75 times the 15 over 60. 15 and 60 are always reducible. That's the beauty of all of these drop factors being a factor of 60. You can reduce it, and then the math is actually, this is some of the most simple math you've done in nursing school. So you take 15 and 60, you reduce it to 1 over 4. So basically now you have 75 divided by 4, and if you do the math, it comes out to 18.7, which you can't do 0.7, so it's 19. But you can see that these are the same rate, but two different tubings, you're going to have to set them at two different rates. So hopefully that makes sense to you, and now we're going to work on some practice problems. Okay, so we have two different practice problems here. First, let me say it doesn't matter what the fluid is. If it says normal saline, half normal saline, D5.5 with 20 a K, it doesn't matter. All that matters are the numbers, the rate and the drop factor. If you know the rate and the drop factor, friends, you can do this. So what I'd like you to do is pause the video and go ahead and work those two problems before you move on to the next slide. Okay guys, so here is the setup and of course the answers for both of those problems. So we started with normal saline at 100 milliliters per hour. I went ahead and put the NS there just for you, but you don't even need it. You could just write your order is for 100 milliliters per hour and your drop factor is 10 drops per mil. So remember, just as a refresher, it's rate times drop factor over 60. Now, what you're going to do is set up the 100 times 10 over 60. That is reducible to 1 over 6. So you have 100 divided by 6. And if you do the math on that, you should wind up with 16.6, which should give you 17 drops per minute. So that's how many drops you're going to count. And hopefully, you know, when you're trying to set that roller clamp, you're going to move that roller clamp up and down until you get it to drip at 17 drops in a minute. If you're successful, then it'll be going at 100 milliliters per hour, which is what the doctor ordered. So at the bottom we have the 150. So now our rate is 150, our drop factor is 12. I just set that up. And you notice I'm not writing all those units, I'm just doing the math here. 12 is evenly divisible into 60 and it reduces to 1 over 5. So 150 divided by 5 is 30. So 30 drops per minute on this one. Okay, here's the next two. Notice on this one that they don't give you the rate straight out. You've got to calculate the rate. So you're going to have to calculate the rate first to have your rate and then figure your drop factor. Okay? And don't worry about the half and the half normal saline. That's just the name of the fluid. Don't let those other things be a distractor and mess you up. So go ahead and pause the video again and work both of these problems. So on this first problem, you have to actually figure out the rate. They gave you the rate in milliliters over 6 hours. So it's 1,000 milliliters over 6 hours. Well, of course, to make our rate times drop factor over 60 work out the best, you need to go ahead and turn this into cc's per hour. So if you take 1,000 and you divide it by 6, you're going to get 166.6, which we know you can't possibly do a decimal on these, so you have to turn it into 167 cc's per hour. Then the rest of it is you just plug it into the equation like normal. So you have rate times drop factor over 60, so that's 167 times 10 over 60. That reduces to 1 over 6. So you have 167 divided by 6. You do that math, and you're going to wind up with 27.8, which you will have to turn into 28 drops per minute. And then down below here we have 1,000 milliliters, but this time it's over 8 hours. Okay, so if you do that math right here real quick, 1,000 divided by 8, you're going to wind up with 125 milliliters per hour. And the drop factor is 15. So plug that in, we get 125 times 15 over 60. That reduces, we get 125 over 4. You do that math, and you're going to wind up with 31.2. So since it's less than a 0.5, we go ahead and round down, and the answer to that is 31 drops per minute. All right, here is your last practice problem. And this one, again, you're going to have to calculate the rate of it, but since you just did it, hopefully you kept some of that and you can just do that a little bit easier. But all that crap with the D5W with 20 milliequivalents of potassium chloride, don't worry about any of that. That's the name of the fluid. What you need is milliliters per hour. So 1,000 milliliters over 8 hours. Take that down to a per hour rate. And then you have a micro drip set. Micro drop sets are pretty consistent on what their drop factor is. So hopefully you remember that. Go ahead and pause the video and work this problem, and then you can hit play. Okay, so hopefully when you work this one, you notice that it has a trick. First of all, we already figured out on a previous question that 1,000 milliliters over 8 hours equals 125 milliliters per hour. So you already had that one. And then your drop factor, it said micro drip. That's always 60. Okay, so when you set it up, it's 125 times 60 over 60, which reduces to 1 over 1, which means that anytime you have a micro drip tubing, whatever your rate is, your drops per minute that you're going to calculate out, it's going to be the same because you're multiplying it by 60 over 60, which is essentially multiplying it by 1. So if it said it was supposed to go at 150 cc's per hour and it was a micro dropper, it would be 150 times 60 over 60. Or you could just know that since it's a micro drop and your rate is 150, your drops per minute is also 150. And if that doesn't make sense to you, then just do the math. It's okay. The important thing is however our brains wrap around it, that we get to the right answer in the long run. Okay, so that wraps up our IV therapy information. If you have questions, please email me or let me know. I will try to answer them. This quiz, for this unit was always planned to be on Proctorio anyway, so just plan to get on there and take that during the prescribed times. And if you have any questions, just let me know.